Can I go forward on the slide again? Yeah, it's good. Is it working? No?
This one?
There it is. Okay, keep going. I've already said this, so keep going. All right. So our first expert from NGI is Dr. Guru Groni. She's the Director of Geotechnics and Environment at NGI, has a PhD in engineering geology, which is different to much of the rest of the panel, if I remember correctly. She's leading NGI's efforts in fields of building, construction, transportation and environmental engineering, focusing on the resilience of critical infrastructure and sustainability of the environment, both on a national and international scale. I think she's going to bring a really interesting perspective because of her position within NGI, with NGI taking some basic research as well as doing very practical work in the consultancy sector. Here to the next one. I feel like the COVID person on TV a couple of years ago now. Next up, we have Professor Giulia Buggiani from the same institution as me, the University of Cambridge. She's currently the Professor of Infrastructure Geotechnics, and she also leads our National Research Facility for Infrastructure Sensing, which is our array of labs that underpins the civil engineering laboratory activities in Cambridge. She's also the chair of the ISSMG TC204, which is for underground construction in soft ground. And her research interests span underground construction, foundation engineering, and also earthquake geotechnical engineering. So we've got onshore, underground. We're now going to transport ourselves via Andrea Rotuno, who's a senior geotechnical engineer at Italfer Spa. He has a PhD in geotechnical engineering from the University of Rome Tor Vergata in coach with the École Centrale of Lyon. And he actively cooperates with universities and research institutes, optimizing design and construction methods, mainly for railway bridge design. So he's on the other side, if you like. We're spanning all the way from Andrea, who's very much out in industry, via Guru, who's at this sort of crossover point at NGI, to academia. And then finally, we'll finish with our last academic in this case, which is a very close colleague of mine, David White, from the University of Southampton. He's Professor of Infrastructure Geotechnics. He's also the co-director of the UK Offshore Renewable Energy Supergen Hub, which is a hell of a mouthful. And his research interests include, a little bit like me, seabed characterization, the design of offshore energy facilities, and he serves on various industry code-writing committees and is an active consultant to industry. So what I'm hoping I can do with Dave's expertise in particular is hone in on one of the conversations we had earlier about the importance of codes and how we can navigate codes being either an enabler or a blocker to technology being adopted within the sector. So that's an introduction to our panel. What I'm going to do now is go to the first set piece question that I sent in advance to all of our panelists here. And that is to go through each of their perspectives on what they think are the key areas of research and development that they're engaged in at the moment that are related to critical infrastructure. So I think what I'm going to do is I'm going to start at the far end with Giulia.
I guess that a lot of the research I do is in connection to issues that have to do with critical infrastructure and infrastructure. If I thought about it when I got the set question before, and I thought that the two examples of things that I'm actively doing now that are interesting are, one is this pile draft foundation, so the behavior of pile draft under complex loading, and this is something, funnily enough, that we've been doing in cooperation with Italfer, so there is also a bridge between two of the speakers. And another one is the application of artificial ground freezing in underground construction, which is something I've been involved with for a long time. It's not such an innovative technique, but for instance, one of the things that was, I think, further down the list of, what is it? For instance, in the UK, it's proven very difficult to try and introduce anything like artificial ground freezing in underground construction because the industry is very skeptical. So maybe now, for the first time, we're having something like that on the Silvertown Tunnel. But, maybe this is another question. So these are the two areas where I've been more of applied research that are more relevant to critical infrastructure for me at the moment.
Okay, so I'm definitely going to return to a couple of those points later from. Andrea, if you could just introduce yourself.
Yeah, thank you. So I'm here, I'm representing Italfer, which is one part of the Italian railway company. And in the last years, I focused on the on foundations of bridges, mainly on geotechnical works in general, let me say. And one issue that we have in mind in our company since 5 years to now, is how to have new solutions, let me say, for problems, in the sense that we have to develop a more sustainable design for our infrastructures in general sense, from the design, from the time of design to the construction time, to the economic savings, and also for contractors, for companies, for people, So this is
So sustainability is playing a huge role. I'm interested. Is that also coming in from an environmental perspective? Is there increasing pressure there?
Yeah, of course. Actually, right now, and that's that we have to build about 400 kilometers in Italy of new high-speed line railway, let me say, and most part of it we have to do it in 2 years, I think. Okay, 3 years maybe. And this sense we have to save time, but also saving time in turn we have a more sustainable, let me say, design and construction. Also for people who are living there right now.
So I think historically price used to drive a lot of decisions, and increasingly sustainability is creeping in. Which way do you think the balance is still? Do you think price is still driving decisions, or where's the?
I think that we have to adopt a win-win approach. For a company, the driver, let me say, is maybe the economic part, and which is strictly connected to time and also to money, of course.
Yeah.
And in turn, we have also more sustainable design and of course more resilient infrastructures. Okay.
Yep, perfect. Thank you for that. I'm
jump in.
Go on.
The comment is that the first time I talked to another senior geotechnical engineer at Iberfe, she was telling me, I started off as a very young geotechnical engineer, and we were designing pile draft for bridge piers, and we were designing very lean foundations. And now, 20 years on, now I'm much senior, and I find that these foundations have gone 10 times as big. The piles have larger diameters, they are deeper. Part of it is due to the fact that over the years in Italy, the seismic action has increased a lot. Not because the country has become more seismic, but because the demand for seismic protection has increased. So our regulation, the design action has gone up. But a lot of it it's escalated to a point where it is perceived as unreasonable. And the first words she said to me were, I feel a responsibility being a senior geotechnical engineer in a state-run company, because essentially the Fed is the state, that I'm wasting all this public money on these foundations that are not really needed. So the first thing she said was, I feel a responsibility to save this public money on the foundations. And I thought, your responsibility is to save all the concrete and steel that are going in there, because that's a huge carbon footprint. So in this case, when Andrea says it's a win-win situation, often, in some cases for civil engineering, financial savings at least in terms of quantities, go together with lean design in terms of saving materials, And so maybe these two things are not, for one time, they're not competing.
Feels like we found a pressure point here that we should explore more. And I'd like to do that. Once I've gone across the full panel here and got their intros, I'm going to come back to the audience and ask you if these are problems that are chiming with you. Is the pressure between price point and sustainability moving? So keep thinking about how you might respond to that. I'm going to come and provoke you a little later. Guru, over to you.
Hi, thanks. I would just like to continue a little bit on this topic, actually, because it's a fun fact. But in Norway, from January 1st next year, all the projects in the building and the construction market is going to be evaluated based on climate change or climate impact, and also on environmental impact. So that means that the government in Norway is trying to reduce the focus on the cost and increase the focus on the climate and environmental impact. And so it's going to be 30% evaluation based on these two factors. And we are waiting and trying to foresee how this is going to be evaluated, actually, because what are the criteria for evaluating different consulting companies and different contractors based on such a general criteria?
But it feels like it's being driven by legislation. It's not changing behaviour naturally.
It's driven by the government.
Yeah.
So they have decided, and now it's up to the project owners to find their way how to implement this actually in the building instruction.
I also get the feeling, and the audience might correct me here, but Norway seems to be, blazing a trail with this as well, with legislation driving a change in behaviour. Is that fair?
See, maybe.
David.
Maybe. Thank you. So I'll introduce myself and maybe pick up on a couple of the points as well. So I'm a geotechnical engineer. My work since moving to Southampton 6 or 7 years ago is all supported by offshore renewable energy, including this funny Supergen hub thing, which I should explain is like a government-funded consortium of universities who are meant to bridge between the research centre and between the research community and industry and government and policy. And that's sort of given me an excuse to keep enjoying working on geotechnical stuff, foundations and anchors and cables and so on. And also how to do site investigations and site characterisation, but then also to spend time trying to articulate what the bigger research challenges that in the research sector we should focus on, and how to understand how to link those to the societal sort of imperative around offshore renewables. So, for example, because COP28 is going on at the moment, so my colleague Deborah Greaves, who leads the hub, has gone over to Dubai sort of equipped with the arguments about how we can support offshore renewables rolling out to support what in the EU is climate neutrality, and in the UK we have net zero. I'm just picking up on some of the comments earlier, like what that allows us to do. We've spent time doing things like studying where you put the offshore wind in UK waters if you need to meet the net zero targets that we have. And ours in the UK are led by the Climate Change Act, which puts an imperative on the government policy to push to net zero by 2050. But then it's really fun to break that down so that engineers and geotechnical engineers in the end can work out what that would mean for the sector. So just for example, we were talking on developing earlier, there was a speaker talking about how you develop the North Sea. So if you need to meet the UK's net zero targets, you have to fill about a quarter of the currently available area with wind farms, which is a huge percentage of ocean space. And therefore, there's a huge question of how you process planning and interaction with other users there. So I've had some involvement in that. Really, only the geotechnics is a really small bit, but the exposure to the bigger questions then provokes us to think about what we do more. And then I suppose the other thing about my background with Julia as well, we've both in our universities been building labs supported by the UK government to do research on infrastructure. So I've had a role in the past few years deciding how do you activate a big lab, a bit like NGI having this campus here to activate, to make it more than just a collection of equipment, have a multiplier effect on being, there's these terrible words to describe, but like things like a sort of hub or a beacon or something, where you can bring together people who can do innovation together and also articulate better to undergraduates and students and so on, where their work as engineers in the future can help solve some of the important challenges that we've had talked about today. So I think Julia and I both enjoyed having this chance to set up facilities, and then the massive multiplier of students and people and everybody going through that facility who can always do more than individual researchers.
And just off the cuff then, in terms of the activity that's coming through both of those labs, what percentage would you say is industry driven at this point in time?
I suppose it depends what you mean by industry driven. I mean, so there's like financial stuff about how much is funded directly by industry, and these probably.
Well, you can describe it in whatever terms you like. You can give the frame of reference if you like, but I mean, how much is fundamental basic research that is for academic inquisition, if you like, and how much of it is looking at a very practical problem that industry has?
Yeah, I guess if you go like fundamental applied off the cuff, you'd sort of say half and half. But I reckon driven by real problems, it's got to always be 80, 90, 100, It's purely curiosity driven without some destination in mind, even if it's like 10, 20 years away.
Yeah. Okay. Julian?
I believe it's been pretty much 50-50. I would say also for us, particularly recent, in the more recent year, we've had quite a few completely industry-driven projects going past our labs. And it's been really connected to HS2, big testing on the strong floor. And it's been fun because, as you say, the good thing is about trying to make this a real opportunity for industry to come to us. Maybe they come in with a specific problem. In this case, they had this really big tunnel, the green tunnel segments they wanted to test. We have a big, strong floor. We have loading capacity. So here they came. And then, of course, they're there for months testing this thing in various configurations and the various load combinations. And you start chatting, and now it looks like, they might be interested in doing some, monitoring of the thing on site, and then you come to the geotechnical monitoring, because all of a sudden it becomes a one-stop shop. You find that you're in a place, and you can tap into a lot of different expertise, which is what we really would like to promote. This idea that, particularly with infrastructure, I think it should never be in silos, I'm structural, so therefore I look at the forces in the members, and then, anything else is not me. But just being in the same place, it was also a very nice journey to be able to be in a new building. I guess it must have been pretty much the same for you, David. And so you can create an entire new culture, because there is no culture that you have to break down before you can do your own thing. So we decided, okay, this is going to be very multidisciplinary. We're going to go all the way from laboratory testing of element testing on frozen ground to something really big, to the entire tunnel. And it's I think that the industry involvement is absolutely fundamental. So you wouldn't have this same level of interdisciplinarity if it weren't real. Because often our more academic-driven researches are a little bit more in our niche. Because you have curiosities, scientific curiosities about things you know very well, that are very well defined. Whereas people come with a problem, and all of a sudden this problem needs a lot of different angles to tackle, and then you end up doing really interesting things, and I think for the good of humanity.
So I'm interested, does this resonate with the audience? We've got a lot of academics here, we've got a lot of people from industry. Is what you're hearing here what you feel about the world at the moment in terms of research and development? Willing victims.
I want to say something.
Go on.
It's not related to what you say now.
It's fine.
Typical. It's related to what the discussion previously, why we don't optimize more. Okay. And this was left a bit in between. So I believe personally that it's a matter of contracting. So the designer usually has a very good incentive to be conservative. Okay. Why should you have a responsibility of failure, right? Now, the contractor, it depends what kind of bidding it was. If the contractor is paid based on quantities, has a very good incentive to build more. If a contractor has given a discount, has a very good incentive to build less. Okay. And usually what happens is contractor gives discount and then finds way to, let's say, to increase. Very often because of unexpected geotechnical conditions. Okay. So there are types of contracting that can help in this respect, and I think one of them, I would like to hear what people from the industry think, is design, build, operate. Because I think in this case, everybody has an incentive to be as optimized and accurate as possible. But perhaps there is something better, but I think in the end it is a matter of contracting, type of contracting, whether we will be able to optimize or not.
I think that design, build, and operate, probably that the argument of unexpected ground condition works also for a company to ask for more money. So maybe not solve everything, but know what you mean. That's what you mean. Okay.
Oh, good. Yep.
For the design and build and operate, probably the only way to actually activate the contractor and having an interest in making a proper and not just most beneficial in a very short view solution. It's quite dangerous though to if we do just a functional thingy, because you will probably usually have an interest to make the cheapest solution, which is probably the least sustainable. But I totally agree to that.
Okay. Thank you. Okay, any follow-ons from that anybody wants to chip in with at this moment? No? Okay. I said I would go off piste a little bit. I have done. I'm going to get back on piste a little bit. So I want to quiz the panel here about what technology readiness level perhaps best describes their research. So is it very basic, fundamental? Is it very, very applied? Is it somewhere in between? Just to get a feel for the sort of spaces they're working in. So I think I'm going to start from either end. David, if we can start with you.
I'm going to answer that after just something prompted by your previous one. So, because I think it's important, this focus on cost. So, if I'm thinking about like energy supply in Europe, the cost of offshore wind is lower than the marginal cost of energy. So it's cheaper than the last bit of energy that you have to buy for the energy system. So everybody continuing to focus on cost is risky, because actually what we need to do is fulfill demand and at the same time meet these other goals, which are sustainability and biodiversity and social impact and jobs, and also security of the supply chain and everybody who just keeps that industry afloat. So I think what we risk in our narrative when we're teaching or when we're just chatting is that everything is about reducing cost, because that's sort of what it has been in the past. But actually, if you think more holistically, particularly with climate neutrality and COP28 and all this kind of stuff, then it's definitely not about cost in the EU, because the energy we're building at the moment is we're building it cheaper. The problem is we're not building it fast enough to get whatever it is, 2,000 gigawatts of capacity in the world of renewable energy in 2050, whatever the numbers are. So I think it's very liberating as well, not just to have to think about cost, but instead have to talk among all these disciplines and balance all these things, and then try to find how legislation can fit. It is tricky because it is always driven by legislation, like the comment before, to force people to change. Because if you are just a particular player, a contractor, consultant, whatever, then it's difficult for you to act. But we have to, as a bunch of engineers who can implement these solutions, take that perspective somehow.
So, which is tricky. Before you go back to my original question, Dave, to summarise, is it fair to say that we shouldn't be worrying about cost so much as maximising value, and maybe the contract type is going to influence the type of value that can be provided? Is that a fair summary, or does somebody want to correct me and interject with something better? I'm going to hold up because I want to get through this last bit a little bit here. So if we can just go across where your research sits, I think that'll be useful for context.
I'll go really quick. So we do like government-funded research on like funny ideas about in situ testing with underground robots to sense the properties of the ground. So we have a project led by colleagues in Bristol University there, through to like making funny tools, which was Sam's work when I last worked with him, that you could actually deploy on ships to measure the properties of the ground. But then we also have very applied stuff where the sort of classic university stuff is to improve on models for soil springs or friction coefficients or pile PY curves. And I count those as like TRL 8 or 9, and just a sort of drop in substitution.
So you've got two extremes there.
And
yeah. Okay, so new tools down at the lower end, 1, 2, 3, and then design methodologies that might be making it into codes at 7, 8, and 9. Guru?
I think that NGI is a private foundation with very little support from the government. It's around 7-8% of our revenue. So that means that we are a highly project-oriented organization, and all our projects are we get in the competition, strong competition with other consultants, with other research organizations, and also research projects. We get them in competition with the universities. So this means that all our research needs to be very, very relevant for the industry because it is paid by the industry.
Yeah.
And also very much of our research is actually done in our projects. We do research and development in the consulting projects that we have. So I guess in terms of the TRL scale, that goes from 1 to 9.
Yeah.
So I think NGI typically does research in the maybe between 5, 6, 7, around there is typically what we do.
So quite a lot of research that you're doing and you're engaged with ends up in practice within your organisation.
Yeah, it's applied research that needs to, the results need to be very relevant for the industry partners that we have.
So are the original sort of research goals driven by problems that you have in the work that you're bringing into NGI?
Yes, I think that was with us from the very beginning of NGI because it's actually 70 years since NGI was founded this year. And our first director, Dr. Lauritz Bjerrum, he said that already in the very beginning of NGI that we need to do some consulting in order to understand what the challenges are and know where we should do our research. But in the beginning of NGI, the first 20 years or so, the governmental we had support from the government of about 45-50%, and that is now down to 7%, even though the demand for geotechnical engineering nationally and internationally is increasing. So something has happened there. But the good thing is that everything is very relevant and applied and needs to be taken into use very fast after research.
Coming at this from the opposite perspective, do you ever feel frustration about perhaps having less space to do some fundamental research?
Maybe not when it comes to the fundamental research, because that is something that I think that the universities are very good at.
Okay.
But maybe doing some more long-term research where you're not quite exactly sure if you're going to succeed or not, because that is an issue when you have the industry paying you for research. It's not very good.
Long term.
Yeah.
Answer was required yesterday.
And you don't know if you're going to succeed or not, and then there is an issue. And maybe there are some research that should be conducted that we don't do because we are not exactly sure of the outcome. That is maybe a frustration.
So, Andrea, what I wanted to ask you is a slight spin on this question, but what sort of problems do you see in your activities with ITAR that make you think, right, I need to get a researcher or a university involved? Just maybe describe a couple of them to me.
Oh yeah, actually, we have this problem that as I said before, this issue actually of foundations, no, and we actually have a lot of questions, okay, that we are actually asking to different universities. Okay, some of them are, for example, related to liquefaction problems below railway embankments, or how embankments really behave if it's founded on piles, for example, which is strictly connected with a previous presentation of our colleague, and there is another sector which is related to hydraulic models, okay, which are most of times in geotechnics are actually our input data, okay, our boundary conditions, okay, for example, again in foundation when we have to build a bridge, okay, and you have a span over a river, okay, you most of times have hydraulic models that are not really tuned with real life service, with the real fluids, let me say, okay. So we have many problems. We want to develop these problems, And we know that universities and academics in general are the key point to solve these problems and to produce, to produce some tools that can be useful in design and construction, because we have another issue that is we must use in design simple tools that are not simple in the sense that are useless, but that must be useful for designers and
So I mean, to give you an example from my world, I might have written a paper that has a constitutive model in it with 12 parameters. I think I have actually done that. No one's going to use that in practice. So what you're saying by simple models are ones that you can use routinely in practice, that you know and understand, they're predictable in sense of what you're going to get from those calculations. Is that what you mean?
Yeah.
So what I'm interested though, what tips you over the balance? What makes you say when you've got a problem, right, instead of doing this research internally, I need to go out and speak to these different universities and get them to do that little bit of research? What is it about the problem that makes it attractive to do that?
Publications mainly. So it's a great point. The publication, the list of publications in which that specific department or university is.
So you mean they've already got an expertise in that area?
Sorry.
So you know from what they've done already that they've got an expertise in a particular area, and that's what makes you go to them. Okay.
Yeah.
Okay. Julian?
I would say I'm a little bit like David, that my research can be at some very basic level and some very applied level. I guess my research covers all technology readiness levels. But what I find interesting is that it is often very, very high technology readiness level research that has motivated some very fundamental research. And I think that this is the most interesting part about the interplay between and this is a real luxury, I think, for academics, that possibly maybe even NGI cannot have this luxury, because, say, I was called in to do artificial ground freezing because they were doing it. So technology readiness level is 10 because it's there in the field and it's being done. And they were doing it, and then all of a sudden they had a lot of problems. So we started monitoring some of these things, and monitoring is research in itself, because you're looking at things that otherwise you wouldn't have known. And so then we had to give an answer. So when they had a lot of problems, they came to the university because they didn't know how to get out of these problems. And we had to give an engineering answer. That is, you cannot give an answer in 10 years. You have to give an answer tomorrow with whatever knowledge you have. But then, the question stays with you. And if you're a good academic, you take it home, and, the behavior of soils under cycles of freezing and thawing is super interesting, from a very fundamental point of view. So, you enter this thing at a very high technology readiness level, and you can take it back very much to the very basic thing. And I think that's what really motivates me, because you can change your heart. You can be a practicing engineer in one point, and on the same problem, you can then swap a hat, because, as you say, we have the luxury, we can take long-term approaches, because, I can continue to think on the behavior of frozen soils for the next 15 years, and I don't have to give any answers. Like, I'm only answering to some scientific...
Well, I hope we come up with some answers.
But you know what I mean? Like, there's this... so, really, and then there are, of course, some other things that are in between. You do things that are at some intermediate level, but I guess I cover the span in many ways.
Does the audience agree? Has anybody got any response to these points? Questions, follow-ups that anybody wants to chip in with? Christopher, here you go.
No, just a comment or question on the or thought on the mechanism, that it's very much high theoretical levels that are kind of triggering the research to kind of is the industrial problems, and we were kind of quite incremental, at least that kind of incrementally improve kind of existing technology. Then we go back, maybe we do basic research to understand those problems better. But that kind of working is it a problem that there is too less, let's say, high risk research project that is really, which is kind of what innovation is about. So we really can take the big leaps
making things in a completely different way rather than actually improving the friction angle slightly on a. Is that a problem? Do you think?
Can I say one thing? Is that there are different, for an academic, there are different sources of funding, and there are some specific, for instance, European projects that particularly focus on high risk, high gain. So, like typically the ERC projects, where you have to come up with something. With maybe it's when you review for these projects, you're encouraged to consider the high gain side of the thing. So you do realize that maybe this does not come to anything, but it's a high risk, high gain. There are other funding agencies that are more down to earth, where instead the doability of what you're, so essentially you have a research program that is very clear in its objectives, in its methods, needs to be done, is a little bit turning the wheel, because there are some research projects where you have to do the work, you know exactly what you're going to do, you know what the methods are, you know where you're going. And therefore, now you're gonna obtain an improved friction angle. Now I'm joking, but what I mean is that you're gonna get some improvement of knowledge, but it's not going to be the big leap because you know already where you're going. So I think that both things are needed, and you have to be clever to find ways to find sources of funding for both. And I wish that more organizations would take the high risk, high gain. It's fair to say that the high risk, high gain is extremely competitive. So whereas there are zillions of programs where you can get some funding for research that is well designed, you know where you're going, there are many sources. When you go to a very high risk, high gain type of, you are competing. So you need to kind of at least convince them that you have some really, paradigm transforming idea that then and there's a lot of competition out there. So the success rates in this type of projects are very low.
Don't remind us.
Yeah.
Other panelists, any feedback or anything you want to add? No? Okay, let's move to the next one then. So the next set piece I sent these people was a question about what had gone well in their research and development projects, and more importantly, perhaps, what had gone wrong and what did they do about it? So if we ever get the question to come up on the screen, that's what it would be. So research projects that you've been running, successes and failures. Who'd like to go first? Guru?
Questions like these are always a bit difficult to answer because NGI is the foundation, 400 employees. We are working in different market areas. We're building a construction market, an environmental engineering market, offshore market. So you're answering like on behalf of a lot of people. So I'm not going to say what is the biggest success because it's very, very hard actually. And I think for NGI, several decades of investment in the oil and gas industry, of course, has been very, very important for us. But I would rather choose an example that is kind of not a typical one for NGI, but it's an example that we are proud of. And that was many years ago, 15 maybe. There was a large consulting project for NGI building a road in an area for many, many kilometers, and the ground conditions were very much soft clay and quick clay that maybe some of you have heard of. It's a very special material that when it can become quite liquid when it's subjected to forces. And the problem in the consulting project that we had was that in order to do ground investigations, we needed to have many, many drilling rigs drilling for months and months because it was in a terrain where there were no knowledge about the ground conditions before we started. So a typical thing at NGI is that some smart people, and we have a lot of them, started to think, how can we do this better? Because it's not very cost effective or sustainable to have many drilling rigs for several months. And then combining technology and knowledge that is already there to make an innovation, that is quite difficult. So one smart geotechnical engineer thought that maybe we should use geophysics. And geophysics is not new, of course, but what if we do airborne geophysics and combine that with the knowledge of the ground conditions and use machine learning and then produce very advanced 3D models. And that was the technology that NGI developed over several years, some with support from the Research Council of Norway, some with support of our own money. And today it's a spin-off company. So 3 employees from NGI left our company and started a new company. And that is a very good success story, I guess.
Yeah, absolutely. So that's a problem catalyzing a new solution.
Yeah,
in a
so
sense.
it's a very typical example of how we work, I guess. Like we see a challenge in a project, and then we think how to solve it, how to make this more cost-effective, more sustainable, and then find a solution for it.
So my feeling is that these problems catalysing new solutions happens all the time, but a lot of the time we don't tell people about it, and we just go, oh, here's a great new thing that we've come up with, and we don't really say where it came from. Any similar stories from the other panelists?
I could have a go. No, I wanted to. You've got this question about, because it says challenges and then how you solve them. So, and I wanted to try and think of one that looks like the Geolab project. So all these Geolab projects that we had described earlier, someone's going and doing a really nice experiment and getting their first few sort of dots, data points. So I thought about this with a project that was actually done with NGI maybe 15 years ago, where the problem was putting pipes and cables on the seabed. You wanted to know the friction, and the challenge was that in soft soils, the strength and the properties get changed by that whole process, and they change through the life of big things. So that's all the geotechnics we need to cover for this problem. But it started off with some experiments here at NGI in a big tank that looks like the Geolab activity, and that just gave us a few dots, and then you could draw bars, and then that solves the problem just for one project. So that's like a tick. And then the problem was, okay, well, what about other ground conditions? And the company had projects in other places. So we then had to go away, and then there was some theoretical work done and some modelling of the first experiments. And then once you had a theoretical model, you could extrapolate to other conditions. So that was then like tick, okay, it's more useful. We've got wider application of it. Then there was a bit of a barrier because there was only one consultant who'd been doing all that stuff, and it wasn't then scalable to other organisations. So then the next step was a joint industry project. So a few organisations came together, and then the method of doing this analysis and forecasting and stuff became more democratic or democratised or something. So then TIC is now a method that like different organisations could use. But then still the developers were worried that it couldn't be certified as something in their designs. So the one after that was to work with some of the verifying organisations, and then in this case it was DMV who came involved in writing a guideline and getting a committee together and getting all that agreed, and then that was okay. So it's sort of tick. It's then specifiable by clients to say, yeah, please use this method, the name. Then it also still sort of involved these big lab experiments. So then it was okay, well, try and encourage the lab testing organisations like NGI to develop small scale, or in this case, it was like a low stress interface test. And NGI like took this on and do loads of these now. And it wasn't really, you know, my particular involvement, but it was like a big group by this stage who were developing this technology. So like TIC becomes more routine and quick and easy. And then there's the fail, which is that the problem is we hadn't organised our data and our databases and stuff. So this all became held in like calculation methods, and you'd want it to be alive and people would update it as more data came in and refined it. But that's sort of not happened. So instead it's now become a little bit stalled and people are tweaking it here and there, but we haven't got our data organised in one place. And I was sent an email, I can share this because we're among friends. So I sent this email 2 months ago by someone from an energy company, and they said, oh, I've got one of your reports from 2012 that do these dots. Can you send me the dots from figure 8 and figure 16 or something? And I have the dots somewhere, but they're in a big spreadsheet, and I probably, you know, I haven't, you know, am I still connected to the organisation that have the name on the front of the report, things like that. So hopefully I've shown you some tips that help you get over the challenges to turn something that looks like Geolab into like real, you know, impact for everybody to use. So we've been bad at data, and like earlier today, the panel really reminded us we sort of need to get good at that to give our work longevity.
Yeah, I mean, it's really nice that the final fail is due to a lack of foresight, and so we're trying to address that right here and right now. Down the other end of the panel, Anything else to add?
One comment on this thing of the data, and then I'll share my history of success and persuasion. So the comment about this is that I have, we've heard a lot about this data, and there is all this thing that the problem seems to be get the data. Are companies ready to share the data? Are they ready to give me the data? The way I see it is not so much that the companies are ready to give you the data, but who's going to curate the data? How are you going to organize it for it to be still available in 10 years, 20 years? Because this costs money. Somebody must be on top of it. You need to pay some people that will be curating the data. So the point is not so much is Yanis willing to give me the data. Okay, he gives me the data, but then where is the data physically kept, and who's making sure that the data is still there, and it's not on a, say, stored on some technology that becomes obsolete and nobody cannot read it anymore. It's not a joke, it's hardly a joke. So I want to say that this data, for me, the real problem about data is not so much, I've had experiences where particularly contractors have been very willing to destroy the data as soon as the job was packed up, because, then you've destroyed the data, there is no more evidence that you did anything wrong. So nobody can point a finger at you anymore, but maybe that's an Italian attitude, I don't know. But
You and Matteo.
Matteo are in the same place, but it's not so much this. I think that the real problem is that these things require effort, and effort is manpower, money, things. And
we've seen this with the Geolab data management too. Just getting people to upload a small bit of data from just a week of testing is hard work.
Yeah, and then you have to curate it, continue to curate it. For me, the success, I want to talk about the success, which is not so much technical. So maybe it's a funny one. It's more a success of attitudes. So I was involved very deeply in the construction of the third line of Roma Underground in the historical center of Roma. And when we started this journey a long time ago, so Roma is a very sparse underground network, because it is quite difficult to put a line in Roma, because other places like London have loads of pile foundations, other infrastructure things. Roma has a lot of Roman archaeology, and that's a problem, because there was a real mistrust at the very beginning of this journey between so this must be the very early 2000s, so it's nearly 25 years ago. There was a real strong mistrust between the superintendent to the archaeological goods and the civil engineers. So the superintendent thought that we were there to destroy, the archaeology, and of course we engineers wanted to build the line, and it was like a clash of cultures. And imagine that the first time we had the document from the superintendent, they put it in writing that the requirement was the construction of the line. So what was the threshold of admissible settlement? It was 0. So they said you have to create 0 settlement everywhere on the line. So I talked to a mathematician friend of mine, and she says, "But that's no problem. You just put a little note there, and you say conventionally we create 0 settlement, everything that is below 10 millimeters." That's something. So that's what we thought. But this is to say, and instead, during construction of the line, through a very, this is the technical bit, that there was, again, we go back to legislation. So there was a thing that was included in the tender. So when the line, the contract was tendered, there was a contractual requirement that whoever was winning this bid, they had to create a technical steering committee to specifically look at the interaction between the line and the monuments. So this steering committee was created. It included, there was Professor Janowkowski in it, Professor Buginel, a number of experts, Kalman Kovari. So it was an international steering committee with all these working groups that were in geotechnics, structure, things. And we did a lot of very positive work. And this created a climate of collaboration, so much so that at one point it became obvious that, for instance, we could do archaeological excavations in the center of Roma, motivated by the construction of the line. And, the archaeologists would have never had the money to do that. So it was nor the opportunity. Nobody's going to give you a license to dig a big hole in the middle of Piazza Venezia. If you have to build a station, of course. And it's an opportunity for knowledge, not just geotechnical knowledge. So that was a big success. That was 25 years later. This is a very working relationship. A lot of good things have happened around this project. It's been really interesting. And I think it was a great opportunity for advancement of knowledge where geotechnical engineering played a major role. So I'm proud of it.
Excellent. Andrea?
I will be short. A success for sure is that one of the new lines that we are building, in which actually we are applying some of these new methods, okay, in order to save money, save times, and so on. So it's I think it's a new not only an approach for this particular project. It's a behavior, okay, that our company, which is the main government company, okay, it's a public company mainly, is adopting, okay, in order to solve problems. So I think that a failure, now a specific example of failure, I don't have it, but a failure would be do not continuing this kind of approach.
Yeah.
So which is also a specific failure. For example, if you have an agreement with a university and the university doesn't care about the agreement, I don't know why. So let me say the project between the two players, the company and university, doesn't go as expected. Okay, it's a failure, but it's not a failure in the general sense, in which you built a structure in which you a company have questions and you must know that there is another player which plays actually in order to answer to your question, to your issues, to your problems. This must be a government approach.
Yeah.
Let me say, and it's important to do that. That standards and legislation also promote this kind of way to do. No?
It sounds like there's a commonality in the sense that success is that bit of research that you've contracted out, coming back and making it into practice, and failures where, like in Dave's case, it doesn't quite make it over the line to routine use. Dave's grimacing, so maybe I've been a bit harsh on him there. But anyway, Guru?
Just comment on what they said. I recognize it very well because when you do a lot of research and development and also innovation in projects, I think that is the biggest failure that we do, because it's left in the project and then we go and do the next project, and there are so many things that could have been commercialized, that could have been the foundation for new companies, for new methodology, for a lot of things, but it's just left there. So that is the biggest failure of everything.
Okay, so the keen-eyed amongst you will notice that I can't count. I've gone 1, 2, 3, 5. And I'm going to finish on this question, and I want it to have two focuses. The first one, how in general, as academics and researchers and consultants, contractors, how can we better ensure that our research is translated into practice, for one? And then more pointedly, how can Geolab do it in the time we have remaining? So who'd like to go first on the panel? And then I'm going to go to the audience to wrap up. Shall I go straight to the audience? Maybe I can do that. Anybody have any strong feelings? What should we do better? What can we do about Guru's problem, both more widely and Geolab specifically?
Yes.
Alka? Can see you looking around. No? Christopher?
No, I think one very important aspect is communication. Basically, talking loud about the value of the research that we do. That's eventually what is going to motivate the industry to do more. So we need to be more clever on that. Engineers are to far extent quiet, afraid of being afraid of bragging and all that. And that's hurt us in terms of motivating industry for doing more research.
I think you have a really nice working environment. I'm not entirely sure it's true for the one I'm from, but yeah, over here.
I was curious what your views were on deliverables from research and what role they can play in getting more translation into practice, because traditionally it used to be a report, a PDF report. Right now it can be a data set, it can be item package, it can be whatever. And do you think that more efforts are required to sort of make the more practical deliverables available to project partners or whoever's interested in it?
Well, that question's got everybody excited. You go first, then we'll go to David, and then finally Julia.
Yes, just also continuing on what Christoph said, that I think that geotechnical engineers need to force ourselves to quantify the value, because it's very often written in research proposals. And when we talk to the industry, we want to do research, and it's all about increasing knowledge and increasing understanding, develop methods. But it's like we need to force ourselves to quantify how much are you going to reduce the cost? How much are you going to reduce the time, and how much more sustainable will something be in terms of climate gas emissions? So we need to quantify that in some way so that it's easier to have this dialogue with the industry, why it is important to do this research. So that is the one question.
So euros, minutes, and tons of CO2. David next, and then.
I was going to echo Christopher's point that we're not very good at selling and explaining the impact from things that we do because we're engineers. But we should take, because this is all about climate resilience, we should take lessons from the climate scientists who, for 20, 30 years, they have to articulate their work publicly, as well as going to technical conferences on climate science and stuff, in order to get their message across. But they've done that now. And so the science of climate change is not disputed, but the engineering solutions and how to implement them, it's sort of our turn to become advocates for what we do. And so the advocacy is important. I think we should take our experiments and our case studies very seriously. So I think Yanis said earlier, your power load test, how much did that cost? And that's an amazing piece of data if it was able to become public. But we shouldn't underestimate that every experiment we do is a real failure with real data, probably with a real site investigation in miniature in the lab next to it. And so we should hold those up with the same value. And then to absolutely echo your point a minute ago, we should articulate what the impact of our work is. So when the Tenet presentation earlier was talking about 2 gigawatt offshore substation. So if that is the key to unlocking a wind farm, I did a quick count. So if that goes into the UK grid, that saves 77 million tonnes of carbon, which is 20% of the UK's annual emissions over its life. So we should be able to articulate things like that. And we're used to, in transport and dam safety, talking about mortality and lives. So if you look at the impact of climate change on lives, then one of those 2 gigawatt farms saves 17,000 excess deaths, to use the language we know from mortality from COVID. Right? So we have to get stronger at articulating the impact of what we do, or we need to gain those skills and work with others, because not every engineer can articulate things in these best ways. But that brings us closer to government and policy and influence. So we should get better at that.
Yeah. So we still need metrics, but not necessarily citations or H-index any longer. You can stew on that one. Julia.
The metrics, I wanted to say something different and much smaller. Now I feel intimidated because I'm talking really big picture here. But, the metrics is a difficult thing because, for instance, the carbon footprint is a very difficult thing. For some things, it's very well articulated, like, concrete structures. You can, you almost have, you download the spreadsheet and do your concrete calculation. For other things, it's much less well articulated. Come to artificial ground freezing, and you have to quantify the carbon footprint of that. That's a bit complicated. You have, and it depends very much where you put your boundaries. Where's this carbon? Am I limiting it to my side? Am I looking at the UK? Am I looking global? And it's you need to articulate it in space and time. And it's not that easy. Or we don't have very accepted, universally accepted, and well-established methodology that an engineer, first year undergrad can learn about and play a little bit with an Excel spreadsheet, as we have for limit analysis. Like, I can teach them to do that. So if we want to get there, I was really interested by you were saying about, now the Norwegian government will base 30% of their evaluation on projects on your, sustainability, environmental. How it's going to be very difficult to evaluate with a metrics, and that's what we need because we're engineers. If we don't have a metrics, it's just wishy-washy stuff, and then be worried about that. I wanted to say something much simpler that was about I can't remember what was the task. What can you give us other than reports? For instance, this has been a constant source of frustration because we in several points in my life, I have developed some things that were very close to things that were tools. So tools that I developed for myself, like at the very, very basic level. At one point when I was doing the Jubilee line extension, I have developed this fantastic spreadsheet that could calculate in real time all the 3D field of displacements, with Gaussians, but I could do all the displacements in all the direction and all the strains in all the direction. I could rotate it and look at it, and it was done on a spreadsheet. Not particularly clever, exactly, with macros, because exactly. And then you say you code it, and then you code it, between me coding my own thing for my use and me being able to sell this as a product to somebody, there is a long, it's a big gap. You need to make it free of bugs. You have to make sure that somebody can use it without knowing how you coded it, what are the bits that you have to do. And I'm not interested. I'm not a software developer.
So that is a gap.
I'm a geotechnical engineer. So I have this tool, and I would very much like for this to be taken by somebody that is a software developer. The frustration I have in not having been able to do that over and over again. So now I said the Gaussians, but there are others. There are more recent ones about pile graphs. There are a number of things that we have essentially working as softwares, but they're not real software. So we would have to have some software developer. Only the people that have been involved into creating the things are not software developers, and they don't want to become. They don't want to go out and become. How do we do that? I have found very few people that have an appetite for doing that for me.
I'm going to go to Christopher at the back, and then I'm going to have time for one last final comment, response, provocative statement, just to close this all out. Christopher.
I had a problem.
Yeah, no, I don't have the answer, but I think there's two things that are important. I think we really keep those engineers who are interested in the, let's say, very, very good coders, in a different way than what we used to have. And I think those engineers are graduate. There are more and more of these people, so I think that is a good thing for us. It doesn't mean that everyone needs to do it, but there will be higher density of these people that can take this. And the other thing is that I think kind of modern cloud-native solutions will make this easy for us, because compared to the old days when this was done by in spreadsheets or in local scripts on a computer, you can now deploy this in an easier way in the cloud based on the data that is there. And there is actually quite much digital infrastructure that makes that possible for you to like local solutions and all that, so you can do it easier. So I don't say it's case closed and it's solved, but I think there are happening things next to geotechnics on basically just general development of modern tech modern tech stacks that make this deployment so much easier. So I think we will get there if we are following up on that.
I want to respond that way. I can't stop.
I'm going to leave Julia to respond to that.
I want to say something of what is important to me.
Andrew, go ahead.
To me is very frustrating, let me say, that I cannot see all players in critical infrastructures in Europe, let me say, here. Because the first thing I think you must knock, let me say, to the doors of people who manage critical infrastructures, you know, for example, railways, roads. Yeah, here there is someone who is working with. So I think that this could be very useful, or could be the line in order to create a virtuous cycle, let me say, okay, a win-win approach again for everyone to have a great changing, I think, no?
So in a sense, you're saying we've got to broaden the church, bring more infrastructure people in, the people who are actually managing the assets, and use them to define the directions we're taking with at least some of our research more towards the practical end than fundamental.
Yeah, both practical, yeah.
Okay, so I promised a provocative statement to finish, and Yanis has promised me he's got one. So Yanis.
Yeah, I don't know. You asked something provocative, so I will put some thoughts. So how can we improve our success of translating research into practice? In general, civil engineering industry, and I think we will all agree on this, is quite conservative. It's a bit slow for innovation from going to practice, right? I know one exception in earthquake engineering especially, and this is Japan. So in Japan, specifically for earthquake engineering, the big construction companies, Shimizu, Taisei, Takenaka, some of them, they all have research laboratories. They have centrifuges, shaking tables. So they have a new idea, they do analysis, they test it, and then they construct it. Okay, so what is the difference? Why Japan they do it like this? What is the difference? I think it's a matter of urgency. It's a matter of survival. They have to do it. Okay, so, and I'm afraid that the problem will solve itself naturally because climate change will bring the urgency. So maybe we don't need to do much. It will happen.
Good idea. It's a wonderful provocative thought to end on.
Have a beer.
And I'm going to have to end the session because I'm told that we have to go for this tour at NGI, which is going to be fabulous. So what I'd like to do at this point is just to give the panelists a round of applause for their insights. Now I think I'm going to hand over to Leigh in an announcement or...